to the next example now. We want to state an interval on which the average rate of change will be negative. Well, when we just saw from the rough sketch of the function, to the left of the vertex, the function is negative, it's decreasing. Therefore, for a negative average rate of change, it'll be going to the left of the vertex, so from negative infinity to the vertex itself. So anywhere, any x values along this interval, anywhere in there where the function is decreasing, will have a negative average rate of change. Okay, and moving along to E. Coordinates of a point where the instantaneous rate of change will be negative. Well, again, if we know that the function is decreasing from negative infinity to 2, as we pointed up here in D, then any x values in this interval where there's a tangent line on the curve, that will form, or that will give a negative slope for the instantaneous rate of change. So, because the function is decreasing, on the interval any point to the left of the vertex will result in a tangent with a negative rate of change. So we could use any point, for example 1, f of negative 1, or negative 2, f of negative 2, or even 1, f of 1, etc. It doesn't really matter, even 1.9, f of 1.9. So any point at all to the left of the vertex, which would be points in this interval here. Okay, so we could carry on and on also if we wanted to, negative 10, f of negative 10. So any of those points, negative a million, as I get ridiculous, f of negative a million. Okay, so for example, the next example here, we've got this function m of x equals 1 over x, and I'm not really sure why it shows m, because m is generally what we use to indicate slope. So maybe let's change that to p of x or something, just to make it a little bit different than m. So for that function 1 over x, we want to calculate the average rate of change on this interval from negative 4 to negative 1, and the instantaneous rate of change at x equals negative 1. And I guess what we need to do is calculate the estimate of the instantaneous rate of change, because we cannot calculate the exact instantaneous rate of change just yet. So again, just a little quick sketch of this. This is a reciprocal function, and generally it looks like this. So we have a bit of an idea. So if we're looking at the average rate of change on the interval from -4 to -1, we're looking at from a point here to a point here. So we're trying to find the average rate of change between those 2 points there. And then for the estimate of the instantaneous rate of change, we want to find the rate of change right at x equals -1 at the point of tangency there, which would be something like that. Okay, so for the average rate of change, we've got f of x2 minus f of x1 all over x2 minus x1. And so when we substitute in the x values here, -4 and -1, I'll use -1 as the x2. So when you substitute -1 in for x, we've got 1 over -1 minus 1 over -4 all over -1 minus -4. So we got -1 plus 1/4 all over -1 plus 4. So we have -3/4 over 3, which then gives us -1/4. Okay, so the average rate of change for the secant between the points x equals -4 and x equals -1 on that interval would be -1/4. So for the estimate of the instantaneous rate of change, again we start out with the average rate of change. Which is f of x plus h minus f of x all over h, 1 over x plus h minus 1 over x all over h. Then we got 1 over, and I'll, because we can't simplify this down much more, I mean we could do a little bit of manipulation, but it's not really worth the effort to get a common denominator here and simplify and invert and multiply with that h. So I'm just going to substitute in the values now. The value of -1. And so then we'll end up getting 1 over -1 plus h plus 1 all over h. And so for the preceding interval, let h equal -0.001, and for the following interval, let h equal +0.0. So for the average rate of change, I'll just substitute in these values into this formula here. So we've got 1 over -1 minus 0.001 plus 1 all divided by -0.001. That's going to give me 1 over -1.001 plus 1, and that will result in -0.999. And then for the following interval, so I'll substitute this value in, and we get 1 over -1 plus 0.001 plus 1 all over positive 0.001. So we get 1 over 0.999 plus 1, and so that results in 1.001. Sorry, this should be negative right there. The average rate of change in the preceding interval is negative 0.999, and the average rate of change for the following interval is negative 1.001. And I'm just going to sneak this in over here. So therefore, the estimate of the instantaneous rate of change is the average of these two, which is negative 1.001 plus negative 0.999 all over 2, which gives me negative 1.